now let's jump into the different type of TTL. So as I said, let me open my PowerPoint. So we discussed about the frame fragment offset, IP flags, identification, TTL. So now we are going back to the TTL again. So when we talk about TTL, there are two protocols being used for TTL. One is UDP based and TCP based. And the values 64, 128, and 255. I think Cisco uses an UDP. We'll do a testing now. And some Linux boxes, they also use a UDP. So whenever there is a routing, TTL is very, very important when you do from any irrespective of your firewall, load balancer, or routers, switches. If a device is capable of doing a routing, and if you expect a device to reach, example, in I can reach a network 192.168.0.1. It can be anything in an example, and it comes with the source traffic 10.0.0.2. So 1, 2, 3, 4. So it is 4 hops away. So the TTL it takes is 4. So if you calculate this, if I do a ping for 192.168.0.1, my TTL should be 4. So what should the TTL value is? I should see in the Wireshark, it should be 60. So it means that there is 4 hops away and my packet is routed properly. But if you see something like maybe 58, but actually there is only 4 hops away. So now it takes 6 hops away. That's not expected. That's something you should focus on your troubleshooting with the routing in the middle. It can be any device, as I said, but TTL is very important to understand. Even I had a scenario where we had a routing problem with Microsoft Teams. So generally, it's a device. They are using an application here. It's a Teams application using here, and there is something this you know the 52 subnet is used for your Teams traffic. It can be anything. In my scenario, I'm telling it's 52 is the subnet used for Microsoft Teams traffic. The user traffic should be authenticated, but for some reason, this routers are receiving this 52 subnet from a different devices from a different routers, but it is something it should go direct internet out from the said end device. But it was receiving this prefixes from somewhere else. And this Teams users are redirected back to that particular boxes and the TTL is too high. Example, it takes 15 hops, but actually it should be the TTL should be 10 hops. So just with TTL, you can figure out, okay, why this traffic is taking 15 hops away. It should be just a 10 hops from my source to the destination. Why it should take 15 hops? It's been redirected somewhere. It's been taking a very longest path. That's not expected. That's something that's the whole point I am telling you. I mean, how you understand your TTL, that helps you for your troubleshooting. There is no one-stop solution for finding all your problems, but how good are you with the protocols, what you understand, and when you apply it with your, your real life, then yeah, you will definitely get, good results, and you can troubleshoot better. So now, when we're coming back to the TTL testing, let's go back here. Let's see what kind of protocol this particular device is using. I think Cisco is Linux based, and most of the devices are Linux based. I think they mostly use UDP based. I haven't tried with other boxes. So for this TTL, I want to increase this TTL value. So I want to bring up this loopback interface. And also these two. I mean, we are going to spin up, I mean, not spin up, I mean, we are going to enable the IPs on these interfaces and let's do a testing again. Because I want to see some TTL decrementing here. So, and also we should see what kind of protocol is used for that particular TTL. So since this is an IP communication, let me do it very quickly. So I'm going to configure this interface Ethernet 0/1, which goes to router 5. Interface Ethernet 0/1, IP address 13001. We are using an universal subnet /24. And also here also we'll change the TTL and let's see this time what happens. And along with that, I mean, along with this TTL, we will also do this fragmentation testing on this particular interface on R2 Ethernet 0/1. I'm going to go ahead and change my IP MTU 1200 interface loopback. Sorry, yep, interface loopback 0. Going to assign an IP address. Since this is a router 2, I'm going to use an IP address 2.2.2 or 255. Going to R5. Host name R5. Interface Ethernet 0/0. IP address 13002 255 255 2550. No shit. So to exchange the routes, I'm going to use an OSPF. As I said, you can do any kind of routing protocol you want. This is not specific to that. Just it's a very simple way of advertising my network. So I'm going to do that. Fake router OSPF1. You can do router OSPF1 if you're doing the same lab. You can enable OSPF on all the interfaces. That's the meaning of this, all zeros, area 0. Going back to R2, network all zeros. Going to R5. Route OSPF1, network, all zeros. Area 0. Okay, from this guy, if I do trace route to 10.0.0, sorry, 13.0.2, wrong IP address, 13.0.0.2. Do you guys know that what is the maximum hop count for a routing? So the maximum hops is 30 hops. That's usually I have seen in many scenarios. It can't be if your packet is going beyond 30 hops, that's not routable. We go back to R5 and I try to show IP route. What do you see there? Can I ping 13.0.0.1? Can I ping 2.2.2? So I'm trying to ping from R5, I'm trying to ping this loop back to 2.2.2. It's on R2, but I can't. I do ping 2.2.2. So neighbor 13.0.0.2, it's a dropping the connection. If I go to, I think it's because of bad MTU. Let me check. Doesn't like an MTU. Let me try. Yeah, because of an MTU problem, I think. Yeah, I think the same thing happening between these two boxes there. What if I try to ping this guy from ping? I'm on R5. I'm trying to ping 10.0.0.1. It's on router 1. I can't. Wipe it off. I can see 10 network. I can reach 10 network through 13. I think it's again because of a bad MTU here. Let me try. It's 13 is flapping and also the 10 is flapping here from R2. Show run interface, Ethernet 0/0. Config face Ethernet 0/0. No IP MTU 1200. Going to R5. I can ping now. So you can see this. So if there is a different MTU on both directly connected devices, OSPF doesn't like it. So that's MTU is very important when you do troubleshooting with your networks. So let me try to do a trace route now. Let me do a trace route to 13.0.0.2. 13.0.0.2. And okay, I want to try this option. If I do with a TTL of 1, minimum and maximum 1. Let me take a capture on this R1, go to capture. The living interface is Ethernet 0/1. So when you're doing a capture, you have to do only for the IP address, the destination IP. 13.0.0.1, sorry, 13.0.0.2. So, so that way you can filter the traffic only for 13. So the TTL what we have given, it's a TTL is 1, 10.0.0.1, 30.0.0.2. So your first packet goes from, what is that? When you do it from for 13.0.0.2, I get a reply, this guy, right? 10.0.0.2 is sending a reply back to 10.0.0.1. Time to leave exceeded. It makes your TTL 0. So again, this guy is sending a TTL, right? Because we made it purposely, we made a TTL value of 1. We made it to 13.0.0.2 and 10.0.0.2 is decrementing it. So I think my packet is not forwarding. So the TTL of 1, I can reach only 1 hop. It decrements the value, make it 0, and I can't, the packet is not moving forward. What if I don't define the TTL? And if you see this is an UDP based. And let's take in Windows, let's see what kind of protocol it's using. It should be in TCP or UDP based. So now if you see the TTL has been implemented to 2. With the TTL value of 2, I can reach the destination, not with 1. If I make it to 1, you have seen the output. This is the output I get with the TTL of 1. So we are not controlling anything with the TTL. What we are telling to this box is, can you reach this box with 1 hop? It is telling, no, I can't. With 1 hop, I can reach only 10,002. And what are the other things you have to look into your TTL? See, for this is a this is a Wireshark and this is a simulation tool. So generally, if it is a 1 hop, maximum it would take 1 or 2 milliseconds. So in an average, right, this is an average. The middle one is the average. This is the longest time it takes. The minimum, maximum value, but the average you have to look always for the middle value. The middle value is your average. So if it is just 1 hop, you should not see more than 1 millisecond. Then it is a slowness problem. See, if you look at this is the first packet. When I sent from source to destination 10,001 to destination 13,002. So apparently 10,002 should send a reply back, right? You guys got the TTL. See, when I make a TTL of 1, I send the packet to R2. It makes the TTL 0 and sends a destination unreachable message to R1. This guy makes a TTL of 2. So it goes here, the TTL becomes 0, goes back here. Then again, since it made us a TTL 2, now it can go for 2 hops. So in every hop, that's how it tries to find the number of hops. So I have to go 2 hops to reach this particular destination. That's the whole meaning of it. And with the captures, what are the key, tiny details you have to look for when you're troubleshooting? It's the slowness here. So the time taken for this guy, 10,002 to 10,001, it takes 4 to 22 milliseconds. And if you look at this particular packet, what is this? It takes 114 seconds, 100 seconds. It's somewhere around 2 minutes. This is not good. And then the production, you shouldn't see something like this. It takes 9 milliseconds. If you see there is in the middle, there is a spike. That's because of the tool is doing that. But when you see the real-time trace routes, you should not see the latency like this. It's just a direct connect. It should not take 10 seconds for it. And how you should calculate your TTLC from here 10,001, now it is talking to 13,002. If you go back to the last packet, if you look at here, the traffic is between 10,002 and 10,001. But the finally 10,001 is making to 13,002 and your TTL is 2. That's your actual TTL value when you reach your destination. Let me check is that I have any TTL related. Okay. So now let's do TTL in the Windows machine. If you see my total hops is 10 hops and all you can see the values here, right? In an average, it is not taking more than 10 seconds here. Everything is below 10 seconds. That's a good connection here. But if you see somewhere around, I have seen in some situations with this trace route, you can figure out your slowness. Which particular hop has a highest value? That's a culprit there. I mean, there is a problem with that particular box. In mostly in the ISP, I would suggest you should ask them for the BGP flapping or some kind of it is doing some kind of very intense task in the box. Okay, now let's do a capture for this. Uh, Let me spin up this Wireshark. I'm interested for here. Let me bring up this here. I'm interested in the traffic 8.8.8. Let me do a trace route back again. The wrong Wireshark. Yeah, this is the file. Yeah. I think still the trace route is going on. So with the trace route, what you should see when you're doing a capture, so it is making to the first hop 192.168.0.135. This is my PC, right? 192.168.0.1. It sends 4 ICMP packets. And if you look at this, I got a reply back from this 10.232.0.1. That's my first hop, right? This is my 192.168.0.1. You can compare with your trace route outputs, you will understand. So side by side. So 10.232.0.1, it's sending a reply back to this guy. So I reached first hop. So I have got a routing. And they are blocking this ICMP in the middle. And this is going to 49.205.72.39. And then finally, if I drop down, so here 8.8.8 is sending a reply back to me. And what is my TTL? So it started with the TTL, it shows us 58 here. So what is the protocol used here? I think this should be using a TCP. Got freezed. So I am telling do a capture for TCP traffic and IP address is 8.8.8. Let me try with UDP. Let me research on this and come back to you. I think it should be a TCP or UDP, but I don't see any kind of specific protocols being used here. So that's how you will calculate your TTL and I think here it is using 64. There in the where is that in the lab Cisco box is using 255. That's a TTL 255 here. So on 128 in some scenarios it uses 128. So your I know the most I have seen the values used in TTL are 128, 255, and 64. So now finally we'll do the ICMP labs today. Then followed by that we will do a spoofing lab next week. So let me open up this. Helps you to understand ICMP related troubleshooting. We'll do. One minute. Let me open this. Okay. So what we are going to look today, I mean, not we are going through all this ICMP codes. The very important and most widely used for troubleshooting is something we are going to discuss. So one of the most useful ICMP codes is something we should know about the host and reachable. So this is a destination unreachable, and it should return with the code 3. So let's do that ICMP testing, and we'll figure out. We'll go one by one. So I mean, we got different types of ICMP codes. For echo reply, it should be 0. It should the destination unreachable is 3. So we are going to try with echo reply and destination unreachable, and how you will troubleshoot with that. I'll walk you through the steps. So this is if you see this code 0, right? So let me go back. So code 0 stands for echo reply. So you get an echo reply back for code 0. So if you see this echo ping reply. So if you want to see only for the ICMP, I think it's very generic. You guys will be using it. You can type in only ICMP will show you only the ICMP messages. Okay, so now we'll do the testing for ICMP destination unreachable code 3. So for that, let me on this. Let me stop all the captures. Start it again. So I got a route for 10002. So let me try to ping an IP address, which is not in my routing table, and let's see what is the response I get. Capture Ethernet 0/1. Going back to R1. Keep it in the top. So let me try to do, I don't know where is 3. Let me do a trace route 3.3.3. Okay, so we'll close this connection. So let me go to R5. So if I do show IPR, so I see 13001 and 13002. Let me try to ping 13005. So let me stop this. Let me just type R packets here. So I got a routing table, can be any layer 3 box. So I got a routing table here. Oh, IP route. So I got a routing table and it costs, it knows how to reach this 30 network because that is directly connected. But I am trying to reach an IP address which is not actually connected in this particular network, right? So all I see for the 13 network is 13001, 13002, and 13005. So my packet will be only forwarded if I know the destination MAC address of it. So it is trying to do a broadcast. Yeah, we discussed this before, the ARP. It's an ARP request. For this ARP request, nobody is sending a reply back. So who is 13002 here? This guy. It is asking the gateway, do you know how to reach this 13005? Right? Because I couldn't find it locally. Because I did a broadcast. Broadcast is local to the subnet. I did a broadcast, but I didn't get a reply back. So if your ICMP packets has to be, when the ICMP packets has to be, what do you say? Without your ARP request, your ICMP packets will never leave, or your ICMP process will never kick in. I would say, precisely if I want to say, if your ARP response, if you don't get an ARP response, you don't see your ARP reply back. If you don't see your ARP reply back, you don't see your ICMP. So your ARP is a base connection for your ICMP. It can be for anything. Correct. And don't confuse with the retransmission and ARP. Some people, they do that. Retransmission is only for TCP. When you completely deal with the troubleshooting, when it comes to the layer 2 and layer 3, all you deal with ICMPs ARP. So in the ARP, I didn't get a reply back. So I don't see any kind of ICMP packets here. So now let's do a simple testing with this. Let me go to our, I'm going to block this ICMP packets here and let's see what is the response we get there. So I'm going to Ethernet 0/1 on R2. Interface Ethernet 0/1. Interface Ethernet 0/1. IP access group. I'm going to just block this purposely to see the ICMP codes. I'm going to say I'm going to say this access group as ICMP. So the traffic is coming inbound from R5 to R2. The traffic coming in, that is an inbound traffic from R5 to R2. So I'm going to block this inbound. IP access list extended. I'm going to use the same name. It has to be same name, the access group and your access list. deny ICMP any kind of ICMP traffic, deny. I'm doing it in R2 and I just logged into the R5 now. Then let me try to ping. I want to ping 13001. If I do a Wireshark, I have to change some value here. I'll tell you how to do that. It's filling up the buffer very quickly in Wireshark. Capture, say Ethernet 0/1. Okay, capture Ethernet 0/1. So when somebody is doing this, even in your firewall, but how do we check that I have a route for this guy? I give show IPR. I can see the destination MAC address. This guy, this is that I know this 13001 is my R2 in the middle, 13001, but it is telling that destination unreachable. But one more thing, it is highlighting that the communication is administratively filtered. So they are blocking it. So I don't see a response. So it doesn't mean that I don't have a connection. I have a connection, but they block the ICMP. Even in the firewall, if you try to ping, you guys will have encountered this problem. They block an ICMP and you can see this communication administratively filtered or something. If you want to probe that this is not actually the devices, the destination is not reachable, it is because of a rule or policy is blocking this, but your actual routing is happening. So this is the proof where you can find it. So if you go to this ICMP packets, so this is code 3, destination unreachable. And on top of that, you get a clue that communication administratively filtered. But I think if you go to the actual box, if you do a debug IPICMP packets all, what do you see for it when you do that? So you have a routing, you're sending a full packet. The destination is this, source 13001, and destination is this guy, PC traffic. But we can't see anything related to the policy filtering, right? But here you can go, you can compare your destination codes, sorry, your type code, and along with that, you will see the communication administratively filtered. It means that the policy is blocking it, but you have a routing. And yeah, what else? But if it, I have shown you, if there is no route for a particular destination, you can't see your ICMP unless you get an ARP response back. So you might be continuously seeing your ARP request. And for your ARP request, as nobody is responding, so your destination is unreachable. That's different from this. So that's a comparison when you have to do when you're troubleshooting. When you ping, you don't get your ARP response back in your capture. So it means that the actual destination doesn't exist. It's not connected to the network. But if you see something communication administratively filtered and code 3, you have a connection, you got a ARP response back. That's why your ARP table has completed your IP and your MAC address detail, but it's been filtered in the middle by any device. That's policy filtering. That's not related to the routing. That's how you can compare your test results and you can do your troubleshooting.